Hello everyone, welcome back to the channel. This is Rahul. Today we are solving a binary tree problem from lead code, that is find elements in a contaminated binary tree. In this video, we will walk through the problem statement. We will explain what all way we can solve this problem and why we are using this approach rather than the others. And we will implement one efficient Java code. Later we will discuss how it work for the examples given, and we will discuss about the time and space complexity. So if you are new here, subscribe my channel, like the video, comment if you have any feedback or anything you have, and get into the problem. So here is the problem. Here the problem provides a binary tree where all nodes value have been contaminated to -1. Now we must recover the tree using two rules. The first one is the root always starts with a value of 0. Second, if a node has a value x, then its left child gets the value 2 into x plus 1 and its right child gets the value 2 into x plus 2. Means the x is the node value. Okay. Once the tree is recovered, we need a find function in order to check if a given target value exists in the tree. So here if you can see, here the find elements is our um, input tree. This is the one we have to change to recovery 1. This is the targets 1 and 2. So here at the initial stage it is -1 and -1. We have to change the root to 0, and the right side, it will be, as you know, we have the formula 2 into x plus 2. Okay, like that we have to do in this one. So let's start. So actually there are two common approaches to solve this problem. First one is tree reconstruction approach. In this one we traverse the tree, reconstruct all nodes and search for the target each time. Actually this is a slow and inefficient approach because every search would take big of n time. And second one is efficient storage with bit set. We can traverse the tree only once and store all record values in a bit set, and later we perform constant time lookups for the find method, and this method is faster and memory efficient compared to others. That's why we will choose the bit set approach because of its faster lookups and minimal memory usage. Now let's move on to coding. So if you are new to tree session, this is the basic structure of a tree. In a tree, there will be a root, a child, means left and right child. That's it. And if you go through tree part, there will be, you can see so many things like parent-child relation, and mm, there will be tree with a root only. Like that, we can tell. So in that way, we can tell. So let's start. We have our class here, find elements. Now we need to um, so here in this main class we will use to solve the problem, and it will store all recovered values using a bit set for fast lookups. So bit set recovered values. Now we have to get into the find elements method. So in the constructor, first set the root value to 0 and we need to initialize the bit set. Later we have to call a helper method in order to recover the entire tree. Okay, for that we will write one helper after this. So first of all we have to initialize the root value to 0. So here we already have these things, only we have to write the method. Okay, so root dot val, then only we can store the value to the root. Now we have to initialize bit set in order to store record values. So new bit set, then we have to call the helper method to recover all values. So I will name it as recover tree root. Once this done, we have to call the helper method. In this recover tree method, we uses recursion to traverse each node, and we will set its value according to the rules and store it in the bit set. So private void recover tree, and we will take the input root tree node root. So we have one base case in this one, that is if the node is null, then nothing to do. Yes, right. So just we will stop recursion at that moment. So if root is null, then return. If it is not, we can go to the second step, that is we have to store the record values in bit set. So recovered values dot set root dot val. Now we have to check if there is a left child. If root dot left not equal to null, then we have to give the calculation here that they already given in the problem. Root dot left dot val is equal to 2 star root dot val plus 1. Hmm? Okay, same we have to do for right after this. Now once we given this, we have to recursively recover the left subtree. So recover tree root dot left. Yeah. So once this done, we have to go for the right side. Same this process only. If root dot right not equal to null, root dot right dot val is equal to root dot val plus 2, and we have to recursively return the recover the right subtree, recover tree root dot right. So once this done, we done with our helper method. Now we have to go to the find. Here we are returning either true or false based upon the check if the target value exists in the bit set. So this lookup is very efficient and it takes constant time of big of 1. So here it takes one input target. Now we have to check return recover recovered values dot get target. Now let's run it. It's working. So now we can just discuss about the time and space complexity. Here the time complexity to recover the tree is big of n because we visit each node once. The space complexity is always big of n due to the storage of all record values in the bit set. Here the find method only um, takes big of 1, which means it runs in constant time for each lookup. Okay, so submit it. It works perfectly. So I will just show you one example. This where yeah, -1 null -1. So and our target values 1 and 2. I'll show you. So at the initial stage, it will be -1 -1, right? Like this, it will be. Hmm? Now we have to change to the recovery tree. Then it will be like at the starting only I mentioned the root should be always 0, right? And I will just give the sorry -1 null -1. I'll just draw everything so it will be easy to explain. Okay, so here I was starting -1. -1 means root. Null means left child. -1 right. So as in this case, the value will change. Like first of all, we have to set the root value to 0. Hmm? That's the first thing we have to do. For left child, there is nothing. So we will give it as null. There is nothing much. If it is null means just ignore. That's it. For right side, the as per the equation, it will be like 2 star the root value plus 2 is equal to 2. 2 into 0 0 and gives 2. And here the value becomes 2. So in this way, it turning minus 1 to 0 2. And as per the question, we have to find the target 1 and 2. So why it's giving null, false and true. So as per this, ignore then this null case. Here false means first it will check for 1. Here there is no 1 in this one, so it will return false. Then find 2, it will return true. As you can see, it is the same we are doing for these things also. So this is the pattern we are doing this problem. I hope you understand what I meant in the example here. So uh, this is the way we can solve using uh, bit set method. So in this video we solved the lead code problem using Java, and we required a contaminated binary tree using recursion, and we stored the values efficiently with bit set. So this approach allowed us to perform the fastest lookups with minimum memory usage. If you found this helpful, don't forget to like, share, and subscribe for more coding tutorials. See you next time. Till that, happy coding.